This is the 7th project in grade 11 computer hardware. For this project, the goal was to create a PCB device that performed a task that would be helpful for future aces in the program. For my project, I decided to create the 2's complement counter. This device shows regular binary counting to 15, binary counting to 15 with the 1's complement rule, and sign counting with the max of positive 7 and minimum of negative 8. I first created this project for my breadboard ATmega 328 project. At that current phase in the circuit's design, it used an ATmega 328P as the processor, did not include an on and off switch, used an external crystal, and used a breakout board for the single pole triple throw switch. I then revisited this project for my legacy PCB, where I added an on and off switch, changed the processors to an ATtiny84, and used the internal ATtiny84 crystal. I first created a prototype to test out my circuit as seen in this video. I believe these additions to the prior circuit design really helped me improve the performance of my project. The PCB works using the ATtiny84 as a microprocessor. The ATtiny84 accepts the same code as the Arduino, but it does not have access to the serial monitor. This is because the serial monitor is run by separate circuitry on the Arduino. The PCB uses the SparkFun programmer to communicate with the computer and can successfully receive code as seen in this video. The code is not different than in the previous projects. When I was coming up with my idea for my legacy PCB, I immediately thought of how much this project would have helped me develop an understanding of the 2's complement algorithm, not just as an example, but in the creation of the code. When I was coding the ATmega 328P, I was forced to develop a solid understanding of how 2's complement counting worked. I think that type of first-hand experience really helped solidify my understanding, and I want to be able to share that with future generations in the ACES program.